Kia ora Year 12 and 13. I'm going to start videoing some of last year's exam papers from Level 3 Calculus, and I thought I'd start with the differentiation paper. So if there's anything you especially want done, just send me an email or leave me a comment. Otherwise, I'll probably just start working through a few questions a night in order. In this paper, in this video, we're going to look at 2 achieved questions and a merit question. So here's the first one, and it's kind of a warm-up. So differentiate the following function, and you don't need to simplify your answer. So let's see what we have to do first. Well, we've got y equals 2x to the power of 3. That's fine. This needs to be put into negative power form. So I'm going to start by rewriting like this. So it's 5 times x cubed plus 2 to the power of negative 3. Right, now what do we need to do to differentiate? Well, the first term is straight out of level 2. It's going to be 6x squared. And the same thing here, except I need to use the chain rule on this bit. So I'm going to bring down this power and multiply it by 5. So it's going to be 5 times negative 3, and then it will be times x cubed plus 2 to the power of negative 4. But I have to find the derivative of the inside function, which gives me 3x squared. Now, that's as much as you have to do to get an achieved tick, but I can't stand leaving it like that, so I'm going to clean it up a little bit. We'll get 6x squared. Putting the coefficient together gives me minus 45x squared divided by this. Okay, so that's 1a done. Let's look at 1b. Right, if f of x is equal to this, show that this is true. So notice that we've got a second derivative in here. So we're going to start by first finding f dash of x and then f dash dash of x. So f of x is 3 times cos 3x. To differentiate that, I need to use the chain rule. Now the derivative of cosine is negative sine. So I'm going to have 3 times negative sine 3x times 3, right? The derivative of the inside function. So I'm chain ruling again. Cleaning that up gives me negative 9 sine of 3x. Now we have to differentiate again, and we get f dash dash of x is equal to negative 9 times the derivative of sine is cosine, so negative 9 cos 3x. But we have to multiply by the derivative of the inside function, which is 3. So we get negative 27 cos of 3x. But that's not what we were asked to do. It's a show that question. So we have to show that 9 times the function plus the second derivative is equal to 0. So now we're going to substitute in 9 times f of x plus f dash dash of x is equal to 9 times 3 cos of 3x minus 27 cos of 3x. And that gives me 27 cos of 3x minus 27 cos of 3x, and that's equal to 0 as required. So there you go, that's the second achieved question in question 1. Right, let's turn to the merit one. We have to find the gradient of the curve y equals the natural log of sine squared x at the point where x is equal to pi on 6. So first we're going to differentiate and get a general expression for dy by dx, and then we're going to substitute in pi on 6. And you might guess that we're going to use a special triangle from Trig to do that. Now there's 2 ways to do this. There's kind of the smart way and the didn't look at it very hard way. So let's do it the not very smart way first. We've got y is equal to the natural log of this thing here. Now we know that when we take a log, the derivative will be 1 over. So dy by dx is equal to 1 over sine squared x. And now by the chain rule, we have to differentiate the inside function. So it's going to be times 2 sine x cos x, right? The 2 sine x part is because this is a polynomial in sine x, and then cos of x is the derivative of sine x. So we've got a chain rule inside a chain rule. So cleaning that up, what do we get? Well, we get 2 cos x over sine x. Now we have to go on and substitute in when x is equal to pi on 6. But first I want to show you the smarter way to do this, which uses our log rules. So y is equal to the natural log of sine squared x. Well, what does sine squared x mean? Well, it's the log of sine x squared. And we know by our log rules that that is the same as 2 times the log of sine x. So dy by dx in this case is much faster. It's 2 over sine x times the derivative of this, which is cos x. Okay, so we get it that way in about 3 lines. Well, it's actually not, it's no fewer lines, it's just easier to make a mistake when we do it the first way. But you'll see that we get the same thing in both cases, of course. Okay, so what I have to do now is substitute in the point x is equal to pi over 6. All right, so dy by dx is equal to 2 cos x over sine x. We've got 1 root 3 and 2 here, and here is pi on 6. So it's 2 times root 3 on 2 divided by 1/2. So that simplifies to give me root 3 divided by 1/2, which is root 3 times 2. So the answer is either 2 root 3, or if we want a decimal approximation, 3.4641. That's to 4 dp. So there you go. So that's all I'm going to do in this first video, because the next two are going to take a little bit more time and I don't want this to go on for too long. So as I said at the start, let me know if there are specific questions from last year's 3 papers that you'd like me to hurry up and do, and I'll speed those up. Otherwise, I'll just keep on chugging through.